Hello and welcome everyone to this SPSS Masterclass. It's gonna be a long and exciting video because at this one video, I'm going to cover so many topics including the data entry, then the data visualization, and the major like central tendency, dispersion, skewness, and kurtosis. And before starting this class, I have a very special announcement to share with everyone. Well, all of you know, I think that in our platform Data Science Era, our objective is to provide online courses, live training on software like Excel or maybe SPSS and programming languages like R and Python. Also, we are planning to offer more and more. So the announcement is basically on SPSS is that after a few days, we have an upcoming training on SPSS for learning data analysis. Okay. And to learn more about this training, I recommend you to check the description box where the registration fee and when the training will start and how long it will be, when the class will start, everything is given. If you want to learn more, I recommend you to contact with this number. Maybe you can message me on WhatsApp or maybe from anywhere. Also, my email is there. It's more convenient to connect with email. So yeah, that's the announcement. Now, what about the content of this course? Like, it's not like about that I'm gonna show everything on the SPSS only. It's like initially I will show you that the statistical concepts, okay? Like what is that, where you can use those methods, like those hypothesis tests or maybe those model. Then after describing the basic idea, then with the real data set, we apply this on SPSS. Okay, and after that we provide you how can you write the interpretation from the output of SPSS. We provide you some real data file or real interpretation file so that you can write report by yourself. Okay, so I hope you understand the whole idea. I believe it's something which is really unique, which is not common, so you cannot find that maybe on other platforms. We believe that is why we are better. And we provide everything, like even after the class, we provide the recording lecture, we provide all our slides, interactive slides or notes regarding for the statistical concepts. Also, we provide all the data set and we provide all the interpretation files. Okay, so everything is there. And regarding the topic, like initially we will start with the introduction to statistics and SPSS. Then we will show you that how the method of data collection and how can you draw some graphs. Also the descriptive statistics like central tendency or other things, and then all the hypothesis tests, all the statistical model like simple linear regression, multiple linear regression, also some advanced hypothesis tests like for ANOVA and non-parametric test. And later on at last, we'll also show you that some of the advanced topic. That is the plan of our upcoming course. All the training may not be in the exact same topic, so make sure that maybe you're watching this video after a month, and so make sure you check our website www.datascienceera.com. Also, you can check out our Facebook page and check out also from other platforms. Okay, and don't forget to contact with us. And to register, please send us a message, especially if you're watching this video from Facebook. Please send us a message in our Facebook page for completing the registration for this course. Okay, so no more further discussion. Let us start this class. And as I said, initially we'll discuss the data entry. How can you enter the data by yourself? Before that, you have to be very familiar with the SPSS interface. Like you can see in our slides, we always provide everything like the procedure of SPSS. Like we'll show you, okay, at first click here, then click here, then click here, and it will provide all the images. Like here you can see what it is mentioned is that in the SPSS, like there is a interface like variable view. You can see in this data set, this is the name of the variable. Here you can see we have around 11 variables, including ID, gender, and some other variables. Also in the data view, you can see that like in this interface, we have the data set view and we described everything. Now let's show it in SPSS to make it or to explain it more easier way, okay? So here you can see I have opened a data file. Now maybe you were watching this SPSS for the first time in your life, don't be afraid. It's very easy to understand. Like you can see, as I said, there are two interfaces. If you click here in the yellow button, you'll get a variable view where the variable name have to be mentioned, the type of the variable and the type of the data set you have. And in the data view, all the answer of the respondents are given, like the data set, okay, like the observation, okay. So let's start with the first variable. Let's say it is ID. So it means that you're asking every respondents, what is your ID? It's like a questions. Every question here is like a variable. And then there is like gender. It's like you're asking them, okay, what is your gender? Now look at the data view. When you click data view, you got the answer. Now you can see that the first person says he is a male, second person is male, third person is female. That is how the answer of all the respondents. And this is the answer of the first respondents regarding all the variable or all the questions. Okay, so this is the name of the variable. And make sure that the rule is that you cannot provide any space in the name of the variable. Like if I say cell began, if I mention that, it will not work. Okay, so I try to give a space, it will not work. And also you can mention any name you want, okay, like give a short name just to understand the variable name. Then the type. Here you can see there are a lot of types here. Like numeric is for the numeric data set. Well, after a few minutes I will explain the different variables like nominal, ordinal, or quantitative. Okay, so you can see there are different options for numeric. Most of the times when our variable has to be numeric, even if it is categorical, we try to convert it on numeric. There are different options like string. String is for like when you have directly the character, okay, and dollar is for like when you have numeric value but it is an amount of like salary you can come out with dollar. Okay, so it's also a type of numeric. And there, when you have a date, you can choose date. So that is the type of the variable type. Okay, and then the white decimal. This is not really important. Like if you provide white value like 8, it will allow maximum 8 character in the answer. Okay, let's say by default you always select 8. Now you can see that here you have manager, clerical. These are the character, right? You have 1, 2, 3, 4, 5, 6, 7, 8. Or like you have male, you have 4 character. So white, this option will allow you that maximum character you want to select from your data set. Okay, maximum character. And this will allow you that how many decimal you gonna allow in your data set. Maximum decimal. Like by default, you can, let's say we are selecting here in the salary option 3. Okay, selecting 3. Now look at the salary data set. After every numeric value, you're getting 3 values after the decimals. So that is how this column works. It's very easy to understand. Okay, so you're done with the first 4 columns. Now let's begin with the number 5. It is named as the level. It will allow you to explain the description or to give a description of your variable. Okay, let's say ID, you are giving your employee code. And this is B date is the name of the variable, but you are giving here a little bit description like date of birth. Okay, and the number 6 is the value. This is the most important one. Whenever you have a categorical data, always include the category here. Like in values, in ID, it's not a category, it's directly quantitative because there is no category. Okay, so here you can see there is nothing in the value levels. Now look at the job time or maybe like minority. You can see there are 2 category here specifically, yes and no. So you can see you're asking them, okay, are you in the minority or you're judging them any other way? It has 2 category, yes, no. So it is a categorical variable, right? Now for the categorical variable, you should mention the category here perfectly. Okay, regarding the missing value, you can see there is 9 is equal to 9 missing value. There is another column named as missing. Well, in this column you can mention all the missing value. Like you can see that you can select here here I'm selecting 0, right? That is whenever I have a missing value in this salary data set, maybe some people don't feel comfortable to tell you their salary, so you're getting a missing value on your data set. So you can define that, okay, all the missing value will be defined by 0. That is how you can select category also for the missing value. Okay, and there are like columns, aligns. Columns is like how many column maximum you have in your data view probably, and a line is like where it will be selected. Like it may be in the left side. Here you can see it is in the left side right now. It may be in the right side. It may be in the middle. So it's not that important. And role is also not that important. But the measure is the most important one. Whenever you have a quantitative variable, always select the scale. Whenever you have a categorical variable, always select nominal or ordinal. Okay, now to describe that more appropriately, let us first discuss a little bit about nominal, ordinal, or scale variable. Okay, so let's discuss the theory of a variable a little bit before we start our data entry procedure. Okay, so like variable usually have two type of variable, like categorical and quantitative, but it's not the actual way to describe the like the classification of the variable. In usual way, we define it by measurement scale, where categorical variable are like nominal and ordinal. But for quantitative, in terms of the measurement scale, we have interval and ratio. But for the analysis, it is okay if you understand these two types, discrete and continuous, which are the type of quantitative. So let's discuss a little bit. Before that, as I said already, in the measure option, the scale has to be quantitative, nominal, ordinal has to be categorical. So what is nominal variable? Where the numbers are assigned to the categories or variable values for identification only. That means you have categories, and where the ranking is not important. So let's say gender. The gender have two categories, like male, female. Now, is it important which one comes first, which one comes second? Not actually, right? Another example, like if you ask someone, okay, what is your religion? It doesn't important Islam is in first, Hindu is in first, or Christian is in second. So the rank here is not important, right? So this type of categorical variable is known as nominal variable. And the next one is the important one. It is the ordinal variable, or in terms of the measurement scale, we can call it the ordinal scale. Okay, it's almost the same definition. So what is ordinal variable, or what is ordinal measurement scale? Like where the numbers are assigned to the categories or variable values in such a way where identification as well as ranking is important. Okay, so that's the difference. Like if you ask someone, okay, what is your economic status, and you're giving them three options: rich, middle class, poor. Now it's really important that middle class has to be in the second position, because here in common sense it really matters, right? So here the categories of the order is matters. That is why this ordinal scale. It can be like, okay, you ask someone a statement, you ask them, okay, what is your opinion about that? We call it usually like Likert scale, like where you have option like strongly agree, agree, disagree, strongly disagree. There are some other example like that. So that is what the ordinal variable. And now let's move forward with the quantitative variable, which usually have two types, as I said, for the analysis, like the discrete variable and the continuous variable. It's very simple, very easy to understand. Like where you don't have any fraction in the values of a variable, it is called the discrete. Okay, like number of phone calls. First of all, it is a quantitative variable because it has no categories. Like number of phone calls, let's say in a day. So in a day, at a day you get 5 phone call, maybe tomorrow you got 0 phone call, maybe another day you got 3 phone call. But is it possible to get 3.5 phone call in a day? Of course not, right? Now regarding the family size, is it possible that you have 5.5 people in your family? So here the fraction is not possible. So that is why family size is a discrete variable, but where you can take any value, like it can be fraction, it can be integer, like height, weight. So like height can be like what, 6.2 feet. That's very much high, right? That can be like 5.5 feet. So yeah, so and weight can be like 60.5 kg or 60.6 kg. So it can take any numerical value. So that's the difference between discrete and continuous variable. So I hope you are very clear with the difference between quantitative and categorical variable. Okay, so now let us show that how can you enter the data set by yourself in SPSS. This is going to be exciting, right? Let's say you ask the respondents 3 questions. What is your ID number? And then ask them, what is your gender? Then you're giving them 2 options, male and female. Then you ask them, okay, what is your age? And you're giving them a fill in the blanks and they're writing their age, okay? So this is a quantitative variable. This is also a quantitative variable, but the second one is the categorical variable, which is nominal. So let's see, this is the answer of the 4 respondents. So the first respondent ID number is 1, and 0 means like what? 0 means female, and her age is 25. and this is the answer of the second respondent, this is the answer of the third respondent. So let us enter this data set for the 4 respondent in our SPSS. Okay, so let's open the SPSS again and just create a new file and then click new, then data, then you got a new file. And in the name option we have how much? 3 variables. Like let's say the first one is ID and second one is gender. As I said, you can give any name you want. Okay, gender. And then the third one is what? Third one is like age, right? That's very cool. And then you have the type. Here, as I said, every type has to be numeric. It doesn't matter, it is categorical usually. Whatever the variable we have, which is important for analysis, we always consider it on numeric. Okay, so then again, like why decimal, these are not important. In the level, you can mention some level which are not highly important for the analysis. In the values here, for the gender, as it is a categorical variable, we have to add some category, right? So ID is a quantitative, so we don't need to add any category. Okay, and age, no need to add any category. So now let's say here our value is 0. 0 for what? 0 for female. Okay, and then just add it. And then 1 for what? 1 for male. Okay, so that's very cool, right? Just add it and then just click OK. Here you got your category, right? So that's perfect. Now regarding the missing value, let's say we don't have any missing value, so let's skip that. Okay, columns, align, not important, but the measure is the most important one. Here your ID is what? ID is quantitative, so you have to select a scale. And gender is categorical, so is it nominal or ordinal? Well, gender have 2 categories, while rank is not important, so just select nominal. And for the age, you need to select a scale because it is also quantitative. Now in the data view, you just need to enter the data. Like for ID, we have the first respondent is like 1. For the second respondent, let's say it is like 2. Okay, and for the third respondent, it is like 3. For the fourth respondent, it is like what? It is like 4. Now let's check the gender answer. Okay, so here our first respondent 0 1 1 0, then 25 35 21 45. Okay, so let's input this. For the gender, it is 0 means what? Female. Then 1 means male. Then 1, then I'm sorry, it's not 2, it's 1 and then 0. Okay, and then that is how you can just enter age of all the respondents. Okay, so this is the answer of the first respondent, this is second, this is third, this is fourth. That is how the observation of the data set looks like in your data view. So yeah, we are done with our data entry part. So let's start the data visualization part and let us show the basic idea at first with different graphs like bar diagram and then like pie chart, histogram. Okay, so let's start with the bar diagram. And bar diagram has also several types like the simple bar diagram, the clustered or multiple bar diagram, also like component or like a stacked bar diagram. Okay, so what is simple bar diagram? Simple bar diagram usually have a single set of numerical data which represents a category. Okay, and remember that here usually we have only one categorical variable and that is maybe representing by a numerical data. Okay, so here you can see that in the example I have mentioned here that here I have like the employment category in the x-axis and in the y-axis we have the frequency. Okay, you can see that we have 3 different categories. Okay, and like it can be nominal, it can be ordinal, that's not a problem here. Okay, so I have to remember the classification of categorical variable. And then simple bar diagram can also have one categorical variable versus one quantitative variable. There is something really interesting. Let's say we have a categorical variable here like employment category, and the quantitative variable we have is like the beginning salary in an office or like in a business. Okay, let's say this data means about that. Okay, so here you can see that the interesting fact is that in the y-axis we have the beginning salary of several persons. Here remember that while using the simple bar diagram in the y-axis, whatever the quantitative variable you can take, it always represents the mean value of that quantitative variable. For example, here the y-axis represents the mean beginning salary. So every bar have several corresponding values for different categories. Now here it always select the mean value. Okay, so that is the idea of simple bar diagram. Now let us start the multiple bar diagram. It is also known as like grouped or clustered bar diagram. Here the difference is that it represents more than one categorical variable. Okay, so it's like two categorical variable. For example, here in the x-axis we have the employment category. Y-axis always like the frequency or count automatically created from this categorical variable. And here we have another categorical variable like the gender. Okay, so that is the idea of like the multiple bar diagram. Here you can see that every category has a difference in terms of the category of another variable, right? And then another cases can happen that like the multiple bar diagram or the grouped or the cluster bar diagram can also have like two categorical variable and one quantitative variable. Like in the y-axis previously it was like frequency or count, but let's say I'm considering here another new variable, salary. And like I said previously, for the simple bar diagram, it always takes the mean value whenever you add a quantitative variable in the y-axis with one or two categorical variable. The next one is very interesting. It's known as like it's mostly known as like the stacked bar diagram. Also some cases it is known as I think like component bar diagram. Okay, the idea between the stacked and clustered is very similar. How it is similar? Here you can see from the first graph, you can see that the bar is in the same. Okay, that both the category are in the same bar. Like for here you have something like education level. Let's say it has also some category like 8 to 10, 10, 12 to 40, something like that, whatever it is. Okay, so here you can see that for the 8 it is like there is a single bar which represents both the variable education level and gender. But on the other hand, you can see that for the clustered bar chart here, for different categories for different variable like the clerical and the female, it is for one bar and clerical for male is another bar. So there's the only difference in terms of the color. You can see that it is in different bars. Okay, so that's the idea of bar chart. Now the pie chart is also very simple. Like it also represents the categorical variable like the bar chart. Okay, like here you can see that it can represent both the nominal data and ordinal data. Usually it is for one variable. Here you can see that we draw a graph for the gender. And let's move forward with the important one like the histogram. Histogram actually shows you the distribution of a variable by visualizing the dataset. Like the distribution follows normal or how skewed the distribution is. It gives you a little bit idea about that, so that you can do the further analysis. Okay, for those variable, and it represents the quantitative variable. There's the difference you must remember compared to the bar chart and pie chart, which is for categorical, but it is for quantitative. For example, we draw a histogram here for current salary. Okay. So yeah, now let's move forward with our data set and just draw the graph in SPSS. So here you can see we have another data set which is named as, let's say, survey. Okay, like let's say we have several variables here like the ID number. Then you can see that in the level option you can read the variable description like the level force, the marital status, number of children, age, like his like highest year of school completed, something like that, and the gender, and the important one like happiness of marriage, like is he or she happy or not happy or pretty happy, or like a stress level in a family or a person. It may be male or female. So you're gonna learn a lot of things about that. Okay, and whenever we draw some graphs specifically, you should have an objective that I'm gonna find this. Let's say I'm gonna find this like happiness of marriage, like why people are happy, why people are not happy. Okay, so something like that. Let's say that. So yeah, now let's move forward with the basic idea here we are going to discuss, like how to draw a simple bar chart or like the clustered bar chart. And interestingly, in my course, or my training, the specialty I believe we have, is that we do not just show you that how can you find the output. We always try to provide that how can you interpret your output. So as you can see, we have an interpretation files here. We will directly provide you that if you enroll our training or our courses. Okay, so you can see that here is that we draw a pie chart like the happiness of marriage for the bar diagram, and we interpret that. So let's draw this variable, like the bar chart for this variable. Okay, so let's open the data set again. So where is the happiness of marriage? So you can see the number 19. The data view, I think, is quite similar for the interpretation we have. Let's see that. The number 19, you can see that where it is. Okay. Here you can see that. A lot of people have different opinion on that. Okay, so let's call the number 19 variable named as the something like that. Okay, so go to there are several ways you can draw graphs. The best way I always recommend is that go to the graphs, then click the chart builder, then click the OK, and then you'll get a new box. Okay, there are a lot of options here. You can select whatever you need for your analysis. Like here, I'm selecting in the bar option. You can see that is for the simple bar, and when you click here, it is saying that the clustered bar, it is saying the stacked bar. So let's say I'm drawing a simple bar diagram. So I'm just dragging it here. Okay, you need to drag it here very carefully. Okay, and then select the variable you need to draw, like the happiness of marriage. I'm selecting it in the x-axis. You can see that in the y-axis, the frequency for this variable automatically created. Now, when you click OK, you'll get your desired output at a new window. Okay, so I'm opening the new window, and you can see that here is the output you got for the happiness of marriage. Now, if you can just make a double click here, and if you just click here, you can see that now you can see the frequency for every bar, like 136, 85, 12. Okay, and you can do a lot of things here. Okay, whatever you need, you can do a lot of things here. Okay, even like when you draw the graph, like I just click the graphs, then the chart builder, then the OK. Here you can see that interestingly there are different options, like what do you want, like which variable you want to select in the x-axis or y-axis, or here you can see that the statistic, you can click the percentage in a state of the frequency. Okay, you know, in practical sense, you're more interested with the percentage usually. So I'm clicking the percentage and I'm clicking the OK. Now it looks very good. I think when you make a double click here and you click here, you can see the percentage here exactly. And if you just skip it, you can see that at your main output, the percentage is shown. There are a lot of things you can edit on that. Okay, so now the point is that, okay, how I'm going to interpret that? That's as simple as you like. So let us open our interpretation files and give you a demo or idea how can you interpret that. So you can see that you can interpret in that way that you can see that from the bar chart, we can conclude that 58.37% of the respondents are very happy after their marriage, right? This is the maximum, this is the highest. And what about the minimum? The minimum is the 5.15%. Okay, like this is for the category for the people who are not too happy after their marriage. And then you can mention the other categories. Like we have only one, of course. Okay, so that is a smart way. You can just mention it, like the highest and the minimum, and then they'll say, okay, these are the like the medium or the remaining categories. Okay, that is how you can say that. So here that is how I interpret the last one, like in between 36 point some percentage of the respondents are pretty happy after their marriage. Okay, so that is how you can interpret a bar diagram. And let us try just show it one more, just give you an example for, let's say, the cluster bar diagram. So go to the graphs, then click the chart builder again in the same way, then click OK, and then now just click reset to start it again. Okay, now I'm dragging the second bar here. Okay, just reset and drag it here. Okay, so yeah, now in the x-axis, let's say I'm going to select another categorical variable. Let's say what it is. Let's say the happiness of marriage in the x-axis like before. Okay, now let's say that I want to find out the relation with the happiness of marriage and the stress level. And a stress level has to be selected here in the cluster on X. Here one category is on another category, something like that. Okay, so cluster on X, when you click here, you can see that when you click OK, you'll get output. Now you can interpret it in the same way for different categories, though you have here more than one categorical variable, but the way is almost similar. Okay, so yeah, that is what the cluster bar chart, and that is how you can draw the bar chart. Now in similar way you can draw a pie chart or histogram. Let me show you how can you do that. So in the interpretation files, like we have the pie chart for what? Pie chart for the marital status, and histogram for the education level, something like that. Yeah, highest year of school completed. Okay, so go to the graphs, then click the chart builder, and then click OK, and then you have to click reset to start it again. Okay, now we are interested to draw a pie chart. How are you gonna draw the pie chart? The same way, just in the gallery option, click the pie and just drag the picture in the middle box. Okay, and then select the variable you need, like the marital status here, the categorical variable, remember that for the pie chart, and just click it here and just click OK. Here you got your desired output. Okay, now you can just find the frequency or percentage in the same way like I showed for the bar chart, and interpret it almost in the same way. Like from the pie chart you could conclude that this percentage are for this category, and which is the highest. This percentage are this for category, which is the lowest. In between, these percentage are for like married, never married, divorced. So yeah, that is all about. Okay, so I hope the idea is very clear to you. Now let's move forward with the last one we're gonna show in this video, like the histogram. Okay, so go to the graphs in the same way, then click the chart builder, and then click OK, and then at last give a reset. In the gallery option, click the histogram. Okay, and click the fast histogram here. Okay, when you drag it here, you get the output. And just to get a final output here, you can see that let us select the highest year of school completed. Okay, so here you can see that we have different variable. So let us select this one, the highest year of school completed. In the bracket we have like eduk. That is, I think, the name of the variable. Okay, now when I click OK, and I got an output. Now it gives you the idea, like I said, the distribution of the variables. Like you can see that it is increasing very slowly. Okay, then it is decreasing very fastly. Okay, so it's something like the right skewed. Though to tell about the shape, we have to rely on skewness more than the histogram. It gives you the idea whether it is normal or not. You can see that it doesn't like look like very much normal. Okay, so yeah, let's get back to our interpretation, how we interpret that. I think that's a very short interpretation we mentioned here, just to give you a little bit idea. In our training or course, we give more interpretation as much as we can. So you can see that here we said that the left tail of the distribution of the variable named highest year of completed is longer. So the left side is longer than the right side of the distribution. That is just to give you an idea how you can interpret that. Okay, so yeah, that is what our data visualization. Okay, so now let's start the ideas of some of the descriptive measures like central tendency, dispersion, skewness, and kurtosis. Let's start with the central tendency. And as always, let us learn some basic, then I will apply in SPSS. So central tendency is a tendency to be a representative value of the data set, the value which other values of the data set lie. That means it is like tendency to be in the middle or central value in the data set. Like some value or some respondents want to be the perfect respondents in terms of other data set. Okay, so yeah, that is what the central tendency. Now there are different measures of central tendency, but three important measures like the arithmetic mean, median, and the mode. So let us discuss this. Arithmetic mean, very simple definition. I'm very sure most of you already know that. Arithmetic mean of a series of observation is like by adding the sum of the observation, then dividing by the number of observation. Okay, so like for an example, like say we have 5 values, 1, 2, 3, 4, 5. Now how are you going to find the arithmetic mean? Just like finding the summation of the 5 number, 1 plus 2 plus 3 plus 4 plus 5, then divided by how many numbers are there? 5. So is equal to 3, that is our mean here. Okay, and then what is median? Median is the middle value of the data set. Okay, like here I have mentioned here for the odd data set. Let's say you have 7 values here. So n is equal to 7, which is odd number. Okay. Now the median will be like n plus 1 divided by 2th position. Like 4th position here is equal to 7. So you can see that for the odd value, exactly the value which is in the middle is our median. Okay. Like before 7, you have 3 numbers. After 7, you have 3 numbers. So median doesn't care about all the numbers. Which one is minimum, which one is maximum. It does not consider all the numbers. Whereas mean consider all the numbers. Did you see that? Okay. Now what about the even number? It's quite similar. The difference is that median is the arithmetic mean between the middle 2 values in the data set. For example, what is the middle 2 values here? The 7 and 8. So here the median will be like 7 plus 8 divided by 2 is equal to 7.5. Okay, so the formula here is not important at all. Our objective is just to learn the ideas a little bit and then so that we can apply it on SPSS. So now one interesting example about the outlier. What is outlier? Let's say you are collecting data set from 10 students in a class. Let's say you are collecting the weight of every student. And one particular student have weight like 120 kilogram. Now look at that, it's very high and it's different from other students. So this number is our outlier, which is different from rest of the data set. It can be very high, it can be very low. Okay, so here we have, let's say, salary data. Let's say we have salary for the 5 respondents. First respondent salary is like $10,000. And then $20,000, then $30,000, at last $200,000. So here it is our outlier because it is different from rest of the values. Well, statistically there are some rules to find out the outlier. For example, we draw a box plot to check the outlier. Here in our class we are not going to show that. We are not going to explain too many topics like that. Okay, so here we just giving you some ideas how can you find that, interpret that. Okay, so I hope that is clear to you guys. Now what is median? Median is like, here you can see that the middle value is the median because here we have 5 value which is odd. So the median is $30,000. Now if you find the arithmetic mean, that means like 10 plus 20 plus 30 plus 40 plus 200, you will get I think like 300 divided by 5. That is the rule of finding the arithmetic mean. So what are you going to get? You're going to get mean is equal to $60,000. Now the question is that which one is most appropriate central tendency, mean or median? Okay, now look at that. Mean is not representing the first 4 values because it is greater than the first 4 values, right? Whereas median is $30,000, which can be the middle of these 4 values, you can say that. Okay, so median here is most appropriate measure of central tendency because it represents most values. Okay, so that is why the median is appropriate when outlier exists in a data set. Now what is mode? Very simple way to explain that. Mode is the number which appears most often in a set of numbers, or the number which appears most time in the data set. Okay, for example, you can see that here 6 appears for 3 times. So 6 is our mode. Very simple, and it is most appropriate for nominal data set. Now let's do a little bit comparison between mean, median and mode. Okay, mean usually appropriate for quantitative data, that means not for categorical data. Okay, and it is really useful for advanced statistical methods, but it is affected by the outlier. Whereas median is not affected by the outlier, and median most appropriate for ordinal data set, which is categorical data, and also it is appropriate for quantitative data only when the data has one or more outlier. But usually even we have outlier, we try to skip the outlier and try to go with the mean because it's easier for the advanced analysis. Whereas mode is appropriate for nominal data set, but it is a less stable measure or not suitable for any advanced statistical methods. So this is the idea of mean, median and mode. Now, what about the measure of dispersion? This is something really interesting. It gives us the idea how the data are dispersed or scattered among themselves. You can just consider it in an easy way that it tells you that how every value or what is the distance of every value from every other value. So it's about distance, whereas central tendency was about finding the middle or central value which represent the whole data set. Okay, now let's consider an example. Let's say you are the boss in office and the office time is 10 a.m. and employer A came at a day like 10 a.m., another day 10:20, another day like 12 a.m., another day 12:30 a.m. So you can see that the distance is very large from one value from other values, right? So he is not consistent at all. Usually we use the term consistent a lot. On the other hand, for the employer B, you can see that this guy is very consistent because you see that the dispersion or the distance is very low from the in the data set. Okay, like what 10:01 a.m. one day, another day 10:02 a.m., another day 10:10 a.m., then 9:50 a.m. So very consistent. That is how you can compare the measure of dispersion. Now there are several type of dispersion out there, like the range, the quartile deviation, average deviation, standard deviation, but the most appropriate one usually in most cases is the standard deviation. So in this video we are going to discuss only the standard deviation. What is standard deviation? It is a number that is to tell you how the measurements for a group are spread out from the average or the expected value or the mean value. So it is like the distance of every other values from the mean value, as mean is the standard or representative value in the data set. So we are comparing the distance from the representative value. So that is why this is a very smart process, and that is why it is the most appropriate measure of dispersion. Now let's give you an example with the formula. What is the formula of a standard deviation? We are not here interested about the formula a lot, but let's give you a look a little bit. Like the formula is like root over summation of xi, all the values minus the mean whole square divided by n. N means how many observations are there. Okay, now you can see that we have a data set, let's say 1, 3 and 5. Here the mean value is very simple, 3. Now how are you going to find the standard deviation? Root over from all the value, like 1 minus the mean square plus another value minus the mean square plus another value 5 minus the mean square divided by the n is equal to 3 here because we have 3 observations. Okay, so that is how you can simply find the standard deviation from a data set. Now the most important one, how you gonna interpret that? Let's say the value of the standard deviation is 3.2 for a variable. Highest year of school completed, this is the name of the variable. That means you're asking everyone, okay, how many years you have completed maximum in your school or your education? That is how you're asking the questions. Okay, then you get the 3.2. Okay, now 3.2 is the variation or the distance from all the values from the mean values. Now how are you gonna explain that? You can say that there is a high variability in the data set because standard deviation starts from 0. Then 0 to 1 you can say okay, it's a little bit low, but 3.2 can assume that it's a very large number for considering the distance or the variation, though it depends on the variable a lot. Okay, now we can say that the average distance between other respondents highest year of school completed and the mean number, so you're comparing all the values and the mean number distance, and which is approximately 3.2 years. So that is how you can find and explain the central tendency and dispersion. Now let us show that in the SPSS with an interpretation files. So here we have the survey data set. Now let us consider a variable and find the mean, median, mode and all the things that we need. Okay, so here in the output we can see that in the interpretation files we find out the mean for the highest year of school completed. Though it depends whether we have to find out first for the variable which measure is most appropriate. For example, here in the marital status we found out the mode because we feel that for the nominal variable, mode is the most suitable measure to explain. And for the ordinal variable, let's say happiness of marriage, we find out the median because here median is the most appropriate measure for the ordinal variable. So let's consider an example. Let us find the highest year of school completed. Let us find the mean, median, mode, and show you the process. How can you find those for one variable? Okay. So now go to the analyze, then click the descriptive statistics, then click the frequencies. There are some other way also. So you can always click a reset to start from the beginning. We don't need to have the frequency table, so you can avoid that. That's not important. Then go to the statistics. Before that, you must select the variable. That is the first job to do. So here our variable objective is the highest year of school completed. So I'm just dragging it here. And then statistics. Then whatever the measure you need, just click here, mean, median. Let's say I'm clicking on, though I am here only interested for the mean, median, mode, and then the standard deviation. Then let's say we also find out the skewness characteristics, which we will be explaining a little bit later. Okay. So the process of finding is similar. Continue and then OK. Now here in a single table you are getting all the output that you need to have. Now what does it mean? Now look at that. It's saying that the mean is 13 point something, median is 14, mode is 12. So it's very close in fact. Yes. Now let's see how we're going to interpret the mean from this. Now here we have to, in reality, we also need to check out the outlier, whether we should explain the mean or median, but both are very close, so we can consider anyone. So we can explain it in that way that from the value, we can see that the value of the mean for the highest year of school completed is approximately 14 years, which represents the center of all respondents. That means all the values in the data set. That is the important term or information you're gonna use for the interpretation. Okay, so that is how you can explain the mean. Now what about the standard deviation here? I already explained the standard deviation is the same thing. Like we are getting the 3.2 here with this high variability. That means the average distance between all the respondents from the mean respondents or mean number of highest year of school completed is approximately that is. So if you got it, how to explain the mean or the standard deviation. Now what about the median? Let's find another for the median. Let's say happiness of marriage. Okay, and let's see how you're going to explain that. It's quite interesting because there is a little bit difference because it is not the categorical variable. So the process is similar. Analyze, descriptive statistics, and then the frequencies. Then click a reset to start again. Avoid the frequency table. You're interested for the happiness of marriage. Just drag it here in the variables. And then click the statistics. Then click whatever you need. Here mean is not appropriate, so I'm clicking only the median here because I'm here, let's say, only interested for the median. And then click OK. Here the median is saying the 1. Now a lot of people got confused. Okay, what is 1? Here you have the category. 1 means a category, 2 means another category. Let's say here you can see that in the variable, in the values options, 0 is for the missing value probably, 1 for very happy, 2 for pretty happy, 3 for not too happy. Okay, so you can see that this is about the categories. Here 9 is the missing value. So let's say there are some categories for the values. Now 1 means very happy. That means 1 is our median. That means this category, our median category. That is you need to explain for explaining or interpreting the median. So let me show that in the files. As I repeat that in my course and my training, I always provide this kind of files so that you can write interpretation by yourself. So you can see that the mode is 1, which indicates, here I'm not about mode, it's about median. Median of the variable named happiness marriage is 1, which indicates who are very happy represents the middle category of the data. You can also find out the mode in the same way. Like here the mode is 1, which indicates married people. It means the most number of people is a married person. Okay, because mode is like the most value in the data set. So when you are getting a category as a mode, it means that this category has the most number. So that is how we can represent central tendency and dispersion. For the standard deviation, we usually only find it for the quantitative data set. Like here I explained it for the highest year of school completed. So that's the whole idea of central tendency and dispersion. So now, what is the measure of skewness? Skewness is a measure that gives us the idea of the shape characteristic. Actually, it is a shape characteristic of a distribution which gives us the idea of symmetry. Well, symmetry in a sense we call it like normal, okay, like how the shape looks like, how the data behavioring, okay. So let's say that here you can see that one example is that in this graph you can see that it is increasing and decreasing almost in the same way. So this shape we call the symmetric, and for this the skewness value has to be approximately close to 0, and usually the mean, median and mode usually is very close. It can be different, it's not always like very appropriate, but the first condition you need to follow for the skewness value is the most appropriate one for finding the shape, okay. So another one here, rightly or positively skewed, you can see that it is increasing very fastly, then decreasing very slowly, right? So this tail or this side is longer than this side. That is why you call that this shape is rightly or positively skewed. And for this, the skewness value always greater than 0. Okay, and usually in this case mean is greater than median. And then the last one, left or negatively skewed. You already understand that how it is or what it is. For this, the left side is longer than the right side. For example, you can see that it is increasing very slowly, then decreasing very fastly, okay. And for this, the skewness value is always less than 0, okay. So that is what the idea of skewness. Now what about kurtosis? Kurtosis is also a shape characteristic, but it gives us the idea of the flatness or peakedness, like how flat or how wide the shape is, okay. For example, we have a very interesting graphs to show here. You can see that this is like the normal, the middle one, right? This is quite normal of the symmetric we call in skewness. So for this here you can see that for this shape it is mesokartic. Here it is the kurtosis has to be approximately close to 3, okay. Now look at this shape. This is less flat, that means peaked than the normal one, okay. You can see that for this the beta 2 has to be greater than 3, and it is known as leptokartic, okay. And the last one, when the beta 2 less than 3, it is known as platykartic, and it is flat than the normal. Look at this one. This is the most flat one, right? This is better flat than this one, and of course from this one is very peaked, that means less flat. That is how the shape idea you can get from the measure of kurtosis. Now let us show that with the example just we had when we showed the what? When we showed the center tendency or dispersion from the data set by using SPSS. So here is the example we have. For the highest year of school completed, the skewness was like minus 0.5, and kurtosis you can see that is close to 1. For the standard error it is close to 0.2. Okay, so now let's see how you're going to explain that. So here is our interpretation file. As the skewness is negative, you can call it that the data are negatively skewed, or the left tail of the distribution is larger than the right tail. For the kurtosis you can see that it is also less than 3. So you can call that the tails are thinner. That means it is more flat than the normal distribution, which is known as platykartic. That is why we just discussed a few seconds ago. So yeah, I hope the idea is very clear to you, and we are done with this long video. I hope you watch the whole video, and if you like this video, don't forget to join our online course or our live training. The description for our online course or live training can be given somewhere in the description box, so you just read it out and you'll get the idea. And if you're watching this video from our Facebook, please send us a message if you want to register or join or enroll our online courses. Also, to learn about details about our online course, please visit www.datascienceera.com. We are still working on the online courses, and it is coming very soon, especially if you are watching this video in the October months. Maybe you're watching this video after 2 or 3 months when all the online courses are uploaded already. And yeah, so yeah, thank you very much. We'll see you another day on another video lesson. Thank you very much. Ta-da!